By 4 simplify. No. Again, leave them improper. 6 over 4 simplifies to 3 over 2. And 8 over 4 simplifies to c to the second. Okay? Not bad, hopefully. Now, okay, you can do caking. You can do this. Now the question is, can you do it all together? So, let's go through an example of something like that. So if I have the third root of 64, a to the 5th, b to the 9th, c to the 11th. And we're going to change that. 128. So third root of 128, a to the 5th, b to the 9th, c to the 11th. Third root. So, to do this, you're going to have to break this down into multiple chunks. Personally, and you don't have to do it this way, I cake first, and then I work with the powers. Then I work with the numbers and the powers. Okay? All right? So, let's start with 128. What goes into 128? 2 and 64. Good. What goes into 64? 2 and 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. 2 and 1. And it's a third root. So I'm looking for groups of 3. 1, 2, 3. 1, 2, 3. So for the number, what do I pull out? 4. 2 times 2, which is 4. So I have 4. And then what do I do with that lonely 2? It goes back in the radical, back in the fridge, right? Now, why did I leave a space there?
Oh,
I have to bring out the variables now. So we've done the number. Now we got to work with the variables. So, now, okay? So if I do what we just did a little bit ago, right? This becomes a to the 5/3, b to the 9/3, c to the 11/3. Yes? Okay? Now I need to see, okay, so a to the 5/3. How many times does that go in whole times does it go into 3? 5. Once. So I pull the 8 out, the single a out, because it goes in evenly 1 time. Then what's my remainder? 2. So where does that go? Back in the fridge. So 1, how many times does it go in evenly? Well, it's 3 over 3, so it goes in once. 3 plus 2 is 5, 5/3. So I'm essentially taking it to a mixed number at that point. So it's 1 and 2/3. So the 1 goes outside, it's whole. The partial, the 2/3 part goes back in. How about b 9/3? 3. Is there any remainder? No. So does the whole thing go outside or inside? Outside. B to the 3rd. And then there's no b in here because there's no remainder. How about c? Goes in 3 whole times. And then the remainder is 2. Okay? So your final answer is 4. A, b to the 3rd, c to the 3rd, times the third root of 2a squared c squared. Okay? Biggest thing you have to remember, anything that does not go in evenly goes back in the fridge. It goes back in the radical. If it goes in evenly, it goes out front. Okay? Are we good or no? Okay, I'm going to give you one more example that I want you to try on your own and then compare with your groups. And then I'm going to give you a little bit of time to finish up the few of these that are on here. And there's only, what, 3 of them, 4 of them? Okay? All right. Fourth root of 32, b to the 7th, c to the 9th, d to the 12th, right and lowest terms. Go. Would you time?
So, yes. So you have to take it times the third root of, yeah, and you do that on the because you gotta put it to something that breaks down. That's like, we have a conversation.
Then once you're done, go ahead and compare with somebody you're sitting near. See if you get the same answer. Sure you want that?
Yes. What do you get your fractions in there?
Yeah.
As hard as it gets.
All right, here we go. So we want to start with the cake or the fraction or the exponent. Cake. Okay. 32 goes in the box. It's 2 and 16, 2 and 8, 2 and 4. All right, bring it back together here. 2 and 2, 2 and 1. All right, so looking for 4 of a kind. There's one group of 4. So the 2 comes out front. What goes back in the fridge? The 2. Now, I get asked the question every year when we talk through radicals in calculus even, what if there's nothing left over? Do I have to rewrite the radical? No. If it's a perfect square and there's nothing left, don't worry about rewriting it. Okay? But you have to make sure everything works out evenly then. Because you might have one where the variables all work out evenly, but there's a number left over. or vice versa. You might have all the numbers work out evenly, but then the variables don't work out evenly. Okay? So now our powers, we have b to the 7 fourths, c to the 9 fourths, d to the 12 fourths. So 7 fourths goes in evenly how many times? Once. What's the remainder? 3. C goes in evenly twice, with the remainder of 1. D goes in evenly 3 times. So your answer, 2b, c to the 2nd, d to the 3rd, times the 4th root of 2b to the 3rd, c. It sounds complicated when you say it, but hopefully breaking it down, it's not that bad.
No, let's see.
Okay. All right. So, yeah, so I can stop this, I guess.